All right. So, hello everyone, and welcome back to my YouTube channel. So, first of all, I will invite you to join my channel with subscribing me so that you can see more of these kind of videos. So, from this video, we are going to discuss about document parser, which is recently released called IBM Docling. So, first of all, if you do not know what is a document parser, a parser is a tool which simply extracts the text content from any given document, such as PDF, Word document, HTML, etc. So the reason for using a parser is a language model cannot understand different document formats, the types. So we need to extract the content, the text content from it and pass it to the language model so that it can consume this text content. So when we are talking about Claude, Anthropic Claude and OpenAI ChatGPT web tools, yes, there is an option we can attach the files and query them directly, but still there is a document parser which is behind the scenes. So when we are developing the LLM based application from the scratch, we need to implement these parsers by ourselves to provide that data to the language models. So here we will be talking about IBM Docling, which is a recently released document parser. And there are several features which this stands out the rest of the document parser. So during this video, we are going to talk about these different features. And also, you already know document parsing is really important for many LLM based tasks, including retrieval augmented generation, which is RAG. So the Docling is wonderful tool, which is free and open source we can use for this purpose. All right, so next I will talk about three distinctive features which stand out IBM Docling from the other document parsers, which I see as important features. The first one is it's free and open source. So there are many paid document parsing tools, especially if you're talking about two major cloud providers. Azure got the Azure Document Intelligence and AWS got AWS TextRack. So these document parsers are really good, but they are paid services. So IBM Docling is free and open source, and the quality of the results coming from the IBM Docling, we can say it is matching with these paid cloud services. So that is a great feature which stands out IBM Docling from the other parsers. The second feature is it does not use any large language models during the parsing time. So when we are comparing the Docling with parsers such as Llama Parse, so these tools use language models to augment the document parsing stage. So a few things. The first one is it consumes our LLM tokens, so it induce some kind of a cost during that stage, which makes them not free. And also there is some kind of a data protection issues because these models either they are using their own private fine-tuned models or the public models. It simply sees our data, so there is some issue with data protection with such approaches. So IBM Docling is free of LLMs during the parsing stage. So that is definitely a great feature, especially the data is sensitive and we do not need to send this data to the outside. The third one is the expert structure extraction capabilities. So IBM Docling, as I said, it does not use language models. Instead, it used fine-tuned table and structure extractors from Hugging Face. So these models are really good at extracting the structures and providing them in nicely formatted text format to the language models. So when we are comparing this with other open source parsers such as PyPDF and unstructured, IBM Docling is really good with these structures. So these are the three main features I would see as important features which makes IBM Docling a really great tool. All right, so next, without much talking, let's move to our Google Colab notebook. So before that, I will provide an overview of what we are going to cover. First, we will talk about installing Docling, which is really straightforward pip install, and then the simple usage example with an online document as well as local file. And then we will talk about the advanced features where we will be setting up the pipelines with various settings. And then we will iterate through different sections or the segments in a document, such as text, tables, and images. Then we will talk about how we can store them separately with the references. And finally, I will talk about some OCR examples. Okay, let's move to the our Python notebook. All right, so this is the Python collab tutorial about the Docling. So this is the table of content. So I will go through each of these components now. So the first step is to install Docling in our environment. So it's really simple. It will be a pip install Docling command. So this will install several supported libraries, such as OCR libraries and table extractors, and also pydantic kind of supportive libraries in the middle. So this will take, it can take up to like 2-3 minutes. And also make sure to restart your environment after installing the libraries, so that we can simply use these IBM Docling in our notebook. All right, so next step is simply to import the libraries. So we need several internal components from the Docling itself. So I will not go into the details of these because these are internal components of Docling. We simply need to import and use them. So in this tutorial, I will be using different elements such as figure elements, tables, text elements, those kind of things from the base models. And basically the document converter is the engine which converts our documents. And also we will be using different pipeline options. So for the advanced mode of extraction, we need to set up the pipelines, and we will be forwarding several pipeline configurations. So these different configurations we need to import from the doclink. So those are the doclink components we're importing, and then we need few other supported libraries to analyze how good it extract the text and to display these results, and also to save the results and to use them as data frames, etc. Okay, so next I will move to a simple, straightforward usage example of Docling. And also I will take a moment to show the Docling JIT page, which is pretty cool. And they have also good documentation as well. So this is the Docling JIT page, and it provides some overview of instruction, how to install, and some basic usages as well. And the documentation you can read it from here. There are some examples as well. So moving back to the tutorial, so this is a simple usage provided by Docling itself. So we are also using the time library to understand how much time does this consume. So I'm using the time starter and end. Then I'm getting the total duration. Then I'm printing that. Other than that, this is pretty much the code of document parsing. So we need to provide the source. So this is a posted document in web, which is an archive paper. This research paper, this is the document technical report. So we have 9 pages there. So we will be providing the URL of that. Then simply converter is equal to document converter. So that is the main class that we'll be using. Simply then converter.convert. So this will create a docling document. So in this case, we will be printing this document as a markdown format. So this is the original document, and after parsing, we are getting this output. So it says, right, so this is the time it took. It took like 200 seconds, which is almost 3 minutes. And then Okay, so there is an image, which is this image right here. And these images, again, we can extract separately. So I will show that in the upcoming sessions. All right, so then the Docling technical report, and then we get all text with, and the good thing is all these different sections are separated in the extracted text as well, which is really cool. So for example, the abstract and the introduction and getting started. So these different sections are separated. If you look at these different groupings, still that structure is also extracted, which is really nice. All the URLs and everything will be there. And this is a table which is nicely formatted in the text with different spacing and with these symbols. So this is pretty cool, especially for a language model. It need to be in the text format, but if we can provide it in good formatted mode, it will definitely yield to very quality results. So this is how good it provide the extraction results. And also these are the references. Again, very formatted and high quality extractions. So this is a simple execution of Docling from this online hosted document, which gives a very cool results. It's very simple and takes like about 200 seconds to extract this entire document, which is not that bad. And all the tables extracted with all the sections are separated. All right, so that's how we can simply use Docling, simply provide the source and then initialize the document converter and then converter.convert, which provides the Docling document structure. Then we can extract the content from this Docling document. All right, so next I will move to examples with the local document. So previously we used hosted documents, this one, and now I am using some local document. So with this code, I will be downloading a sample PDF file. This is again sample document from Docling, a research paper. So this code will be simply, I have this PDF file in my Google Drive, and with this code, if you run this, it will simply download it to your Google Drive. So this is that downloaded PDF file. So when we are using this file with Docling, it's pretty much the same. So this is the code. Again, I have the time extractor to find how much time does it take. So the code is pretty much the same. Here as the source, we are simply providing this PDF file path. So previously it was a URL. So now it is simply this our file path to the PDF. So it will do the same, and it will extract all the tables in very nice format. It will separate all the different sections, so which is really cool. We can use this for uh, the in LLM based applications. All right, so that's how we can simply use a local file with the document parser. Right, so next I will talk about some advanced features of Docling. So simply we are going to use customize parser class to extract different segments from our document. So in this way, we need to set up a Docling parser pipeline. So previously we used doc converter is equal to document converter, and within bracket we did not give anything. But here we will be providing some parameters, the format options and input format .pdf in this way. So this is the PDF pipelines, and inside it we are providing the pipeline options. So this is the customized use of the document converter class, and here we are specifying all the pipeline options. So for example, in this case, I am going to extract the images from my document, and I'm also going to convert my pages to the images. So this is a really important use case. For example, in sometimes when we are providing the images to the language model, it behaves a lot better than extracting the text and providing it. So the vision enabled language models are there. So in such cases, this can be important. So I'm providing some options. First one, image resolution, scale, and these are the default values. And then I am providing the generate page images to true and the generate picture images also to true. The picture corresponds to the images embedded in the document itself. So if you look at our previous example, if there is some kind of an image, it just denote there is an image. It does not actually produce or extract the image from the document. So with this advanced pipeline, we can enable it to generate the image as well. So these are the different options. There are some other options also in the documentation. So for this, I will be using these pipeline options to extract the images basically, and then creating the converter object, and then simply convert. So this is again, I'm using this sample document, and I can simply pass my document with the .convert function call. So this took 215 seconds, which is quite fine. All right, so after doing this extraction job, I will be getting some of the metadata, which provides an overview of my extracted document. So first of all, I can get the document name, which can be useful in many cases, especially when we are doing the batch processing where we do not have the names in our hand. We simply blindly extract all the data from a given folder destination. This is really important. With the result output from the converter.convert function call, we can simply call .document.origin. Then we can get all these metadata. File names, the MIME type is the document type. Docling currently support 4 different document types: PowerPoint presentations, Word documents, HTML, and the PDFs. So we can get which type it supports, which type that we have passed. And also the number of pages is again a good metadata of a given document. And then also the text, this Docling parser extract all the text element from this document. So we can get how many text elements are there. So the result.document and converting it to a dictionary, then we can simply call this text key. So it gives, and then we can get the length of it. It gives how many text elements we have. In this document, we have 512 elements and 9 pages, likewise. So then we can get how many tables are there. So we can use the same thing, converting it to the dictionary and calling the tables key. Similarly, pictures key, it gives how many images are there. So this is a good overview of the document, which shows how many pages and how many tables, how many images, and in total, how many text segments are there in my document. So some of the metadata extraction with this. All right, so next I am going to go through this extracted result through my image extraction enabled pipeline. Then I'm going to print all the text elements from this. So first of all, I'm converting this result into a dictionary. So this dictionary comes with these keys. It contains schema, version, name, origin, furniture, body, those kind of stuff. So I'm interested about this text key, which gives different text segments in my documents, and the pictures stand for the images and the tables. Then if there are some key value pairs, it will be there here, and all the pages will be in this element. All right, so the body contains all the body, and these contain several other metadata. Okay, so in order to extract all the text from the results body, I am getting the text key, and then I'm iterating through it. In this case, I am getting the reference. So all the text are mapping to some kind of a unique identifier, which is the reference. This is important when we are finding different text segments and mapping them to the images and tables, and also especially during the intelligent chunking, we can use these text references. So that's the importance of Docling. It do the structured document parsing. We can use it for better RAG applications. So when I'm iterating through all the text units, each of these text units contain a reference and the text body of it. And also important thing is which page this belongs to. So I can get it from this pro key and the zeroth element of it, because it's in the list format, and the page number responds to the which page this text unit belongs to. So I'm nicely storing all of these in a dictionary, and I'm building a pandas data frame. So this is how my result looks like. So if you click on this table icon, this will be converted into actual table. So here you can see the index column, and then these are the different references of the text. So this is really cool because with this we can refer to the correct text unit, and then it shows which page it belongs to. This contains many text items. Right, so this only shows the text items of the first page, and these are different contents. So it shows only the first 500 characters in the text format. So we can iterate through different pages. Okay, so right, there are many pages, 9, 8, likewise. The text reference, which page it belongs to, and the text content of that particular text unit. So likewise, we can extract and iterate through different text units in our parsing result. Likewise, we can also go through all the table units. So again, results body, I am getting the tables, then simply iterating through all these tables. The tables again contain the reference, which page it belongs to, and also if there are some table captions, we can extract that caption as well. So, and also the table data is provided in some kind of dictionary or the JSON format, so we can extract that. So if you run this cell, it will provide these table data. Again, if you move to the tabular format, so the table reference, which page it belongs to. In our case, there are 5 tables. These are the different references and which page this table is located. And the table caption, of course, it is a text. So it gives the text reference of this. So if you merge this with this text table, you can map all the captions. And this shows the table data in the JSON format. So you can fetch that. All right, so that's how you can simply extract all the tables. And similarly, I will get all the images. So the images, again, the image data is not visible here, but again, I can get the image reference and which page it belongs to. I have 6 different images in the first page, third, fourth, fifth, sixth, and ninth. And these are the caption references. Image data, obviously, we cannot show it in here in the text format. So simply, I want to show you how well we can traverse through these structures, which we are getting from the Docling document. So you can run these cells and customize it in the way you want. For example, if you want to grab all these tables and along with their captions, you can simply use this code to fetch the captions from the text units, and then fetch the tables from the table units, and then nicely organize them in a different another document, right? Okay, so that's how you can iterate through different elements of the Docling document. Okay, next I will talk about how can we iterate through the pages, because in a document, pages are important. How the pages are structured itself provides us some kind of a structure. So here I'm using this function to simply display all these images. So it simply uses the matplotlib subplots to nicely organize all these images in our document. So I'll be using this firstly to extract all the pictures from the document and show them, as well as I will use it to extract all the pages as images and show it. So this can be again useful in various analysis. So the page images, because if you can remember from the pipeline, we have enabled this option. Pipeline options generate page images. True, which means all the pages will be converted into images and will be passed along with the Docling document parsing. So if you run this command, if you run this code, simply from the results dot document and dot pages and items, with this you can get the which page it is, page number, along with the page as an image. So page.image.image is the image version of the page. So this will simply provide all the images from the document. So here I can display them. So I will run this. All right. So this will grab all the pages from the document and view to me as images. So this is pretty much the entire research paper that we are passing. And also what this will do is this will go through all these pages. All right. And in addition to that, rather than simply viewing all these page images, we can also save them as images in our local drive. So if you run this, it will iterate through all these page images and provide it a name. I'm providing the page number itself as the image number. And then we can simply save it through the pillimage.save command. So here, if you run this, it will create this folder pages, and it contain all these 9 pages as images. So I will open one. This is my first image, and this is my 6th page. All right, likewise. So yeah, these are cool features of Docling. We can extract pages as images, and then we can simply view it or save it in our local drive. All right. So next, the actual images, meaning the figures in the document. Again, we can run similar code to extract them. So here what I'm doing is I am getting the converted results dot document, and then I'm running this iterate items command. So with this call, it will simply provide all the items. Then I'm checking whether this item is a picture item, which is a figure. So if that is the case, I will be grabbing this image and I will be saving it as image in my local folder. I will be creating another folder called images, and then I will be extracting all these images and save it into a separate folder. And also I will use this previously defined display images function to display all the images as well. So I will run this, and it will extract and save all the images from my document provided. Okay, so if you go to this images folder, again, you have 6 different images. You double tap on that, it will give nicely extracted these images. This is for the first image. This is my second image, likewise. So if you run this one, again, you can see all these images nicely provided as subplots. So these are 6 different images I have in my document. So that's how you can extract all the separate images from your document. All right, so moving forward, tables. Again, one of the great features in Docling is to extract all the tables in a nice format. So here I will be creating again a folder to store all these tables. And these tables, again, we can extract in various ways because table is nicely extracted from Docling as a JSON. So we can convert it to any format we want. So what I'm doing is I'm iterating through all the items and I am checking this item, is it an instance of a table item, same as the image option. So next, what I will do is, first of all, I will save this table as a figure. That can be really important because with that we can understand the exact way how this table is available in the document. So I'm saving these tables as images, then table as CSV files, which can be really useful for our analysis, and also these tables as HTML files. So here is a typo, should be HTML. All right, so that's it. Getting all the tables and saving them as images, CSV files, and HTML files. So the images we will display using the display images function we defined before. Right, I will run this. So, okay. Now, this should create. All right, so now if you look at this tables folder, which is just created, there are 3 folders. So the CSVs, which I have all these my 5 tables in CSV format and similarly in the HTML format and as images. So first of all, as we have created the images, let's display these images. If you run this, it will show all these 5 images. So these are the all tables that I have in my document. And also I have saved them as images and the HTML and then the CSV file. So I will open up the first CSV file. Okay, so it just looks something like this, which is very nicely extracted. I can use this for different pandas data manipulation job straight away. So it is really good, very high quality table extractions with Docling. And again, with HTML, I can use it for several other use cases in really cool HTML format. I have the tables. All right, so these are the images. No need of opening these images again. So that's how I can nicely extract all the tables from my document. All right, so that's how we can extract different elements in our document and then iterate through them and display and also save them. Okay, next I will also talk about how we can use Docling for the OCR, so the optical character recognition, because sometimes we have the documents which are scanned copies, which can be images basically. Most of the document parsers struggle to extract these documents. So here I will be downloading 2 files. uh, First one is a scanned bill and the second one is a scanned document. So, right. So now I have downloaded them. So if I refresh this, yes, I have this scanned bill, the PDF, and then the scanned doc. So let me, yeah. Okay. So now I have downloaded them. So, right. So next, again, I need to create a pipeline for this. We can use the same pipeline before enabling the OCR options, but here I'm creating a new pipeline. So here we need to give this command in our pipeline options. Pipeline options do OCR, set it to true. All right. So then as the OCR options, I am using the easy OCR options with forced full page OCR enabled as well. Okay, so that's pretty much it. I'm enabling the OCR and then I'm providing the easy OCR as my OCR option. Then I am using it to extract my documents. So this pipeline is OCR enabled pipeline with Docling. Same thing, I am using passing these pipeline options inside my document converter object. Right, so I will run this. Then I have downloaded this scan bill and scan document. So let's run this first one. Here I will be passing it through my OCR parsing function, and then I will be I will printing the extracted text content from it. Next, I will also show you the actual document. Okay, so this will take a little bit of time, about 1 to 2 minutes. So I will fast forward this part. All right, so now this extraction is completed and it took 100 seconds. So this is what I have as the extracted text content from the document. So if you look at the original document, so this is my scanned document. So if you compare this to, right, so this has the text content, from the document, and this is the actual document. So it gets the, right, the remote work is there and how to overcome the common struggles of the working from home. So you can see this is a header. It has extracted it as a header. It shows this indication and written by Kelly Benitez. Right, so all the text as 3 paragraphs, again, nicely formatted, I have in my result. So which is really nice. So entire text is there. I think it has exactly extracted this. I went through this and it has nicely extracted all these documents. So the OCR functionality of Docling is really nice. It's very well formatted and nicely extracted. So that's how you can use Docling for the OCR. This is one example. So I will go through another one. So here I have a bill, which is a little bit complex one. So this is what I have in my bill. Starbucks store 7240, blah, 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 and some address and some values. So let's see what it provides. Okay, so it took 88 seconds, and okay, it uses Starbucks, which is not exactly correct, and 724 is correct, and the address is there. The Washington is separated. So this is not very good, but still, with given the complexity of this job, it does a very good job, I would say. So it tries to grab the content, especially if we pass this to a language model, it can feel some of the missing parts. Basically, it can fix some issues. It can combine the separated words and etc. But still, the content-wise, it has done a good job to extract the content from this scanned document, given it is a distorted, complex scanned document. All right, so that's all I wanted to cover from this tutorial. So here in this tutorial, we discussed about um, IBM Docling, and we went through how we can initialize it, install it, and use it with the simple examples as well as advanced pipelines. And most importantly, we nicely extracted different units from this document, such as text units, tables, and the images, and then we manipulated them, we saved them in different ways in our local file so that we can use it for the later usage. So overall, in conclusion, Docling is a really good document parser which provides structured, extracted results. If you see in the results with the research paper, it nicely separates all the sections, all the images, and the headings, and even the item groupings. So this is a really good document parser. So I will provide the link of this tutorial in the description. So that's pretty much it. So thank you for watching my video. Make sure to subscribe and share it with your friends. Thank you. See you in the next video.